Hello, this is Mrs. Sargent, and this is lesson 3.7, Periodic Trends. So, with the way our periodic table is organized, there are specific trends for how the elements are arranged. Today we're going to look at atomic radius, ionization energy, and electronegativity, also known as electron affinity. Coulomb's law is the attractive force between two charges. It depends on the magnitude, which refers to the size of the charge, and the distance between the charges. So electrons are negatively charged, and they are attracted to protons with a positive charge. Here in this first diagram, we want to determine which is going to have a higher force of attraction. There's one positive charge, one negative charge in each of these pictures. The thing that is changing is the distance. Well, the top one here is going to have the greater force of attraction. You can think about this like if you have two magnets and you have one magnet on one side of the room and then someone on the other side of the room holds it. There's going to be attraction, but the attraction's not going to be that great. Whereas if you're holding a magnet and the person sitting right next to you is holding a magnet with the opposite end facing towards you, the force of attraction is going to be a lot greater. So here in our picture, the magnitude is the same. But the smaller distance results in a higher attraction. So here, still looking at Coulomb's law, we have the same distance for all three of these and the same negative charge for all of these, but the magnitude of the positive charge is increasing. So since the distance is the same, the greater magnitude results in a higher attraction. Nuclear charge is the total charge, which is equal to the number of protons in the nucleus. Nuclear charge increases with increasing atomic number. So as we go across the period, our atomic number increases, so the nuclear charge is going to increase. As we go down a group, the atomic number increases, so the nuclear charge is also going to increase. Shielding effect. Shielding effect is when the inner electrons block the outer electrons from the attraction to the nucleus. This creates a new effective charge, which is the total pull on the outer electrons. The shielding effect increases as you go down a group. Each period adds a full octet of electrons, which increases the distance. So think about it like this. If you go to a concert and you are in the front row, you are going to have a very different experience than if you are 50 rows back, because the 49 people that are in front of you are shielding you from that experience that you would have had in the front row. Shielding effect is constant as you go across a period because the electrons are added at the same energy level, but the nuclear charge is increasing because the atomic number is increasing, which means that those valence electrons are going to have a greater attraction to the nucleus. So the shielding effect remains constant as you go across a period. Atomic radius is half the distance between two bonded atoms. This indicates the volume of the atoms. We said when we were talking about Schrodinger's model that we don't know the exact definition of the atom because of all of the possible locations for where the electrons could be. So we can only measure the volume of an atom when we have two bonded together, and then we can measure from one nucleus to the other to get our radius. As we go down a group, the atomic radius increases. If you look at group 1A on your periodic table, find lithium, and then below it sodium, and then below that is potassium. As you go down, each period adds another shell of electrons, so the overall size of our atom is increasing. So with atomic radius, we have increased shielding. Each new period adds another shell, which increases the distance from the valence electrons to the nucleus. As you go across a period, the atomic radius decreases. So here's a picture showing sodium through argon. The size of the atom is decreasing. Well, our shielding remains constant as we go across that period, but the nuclear charge increases. The number of protons in the nucleus increases. This is going to pull the electrons, the valence electrons that are in the same energy level, closer to the nucleus. We'll come back to this in just a second. So here's just a learning check to see, check out if we can understand which would have the higher atomic radius. Whenever I'm doing these, I like to make a little outline of the periodic table because I'm a visual person, and so this helps me think about the trends. So we said that the atomic radius, as we go down the periodic table, down a group, it is increasing, and as we go across a period, it decreases. So sodium is about right here, and potassium is about right there. Well, potassium is farther down. It has another shell of electrons, so it's going to have a larger atomic radius. And then if we look at sodium, which was right here, and its next door neighbor, magnesium, to determine which has a bigger atomic radius, well, sodium is because it has a smaller nuclear charge, so the electrons are not pulled as close to the nucleus. And then our next one is aluminum and bromine. Well, this is a little bit harder, but if you take a look at your periodic table, they're not in the same group, they're not in the same period. When we go down, we increase. But then we decrease. So if you see, we are decreasing by 1, but then we're increasing, and if you could just count the blocks on your periodic table, you are decreasing by 1, 2, 3, 4. So aluminum is going to be bigger than bromine. Ionization energy is defined by the amount of energy required to remove a valence electron. The higher the ionization energy is, this means more energy is needed to remove an electron. So our metals, we said, often lose electrons. They're going to have a lower ionization energy. And then our non-metals tend to gain electrons. So they're going to have a higher ionization energy because they're not going to give up their valence electrons that easily. Ionization energy has a lot to do with the size of the atom. As we go down a group, ionization energy decreases. So if we think about the attraction for our valence electron to the nucleus, as the distance increases, there is going to be less attraction, so less energy is going to be needed to take this electron away than it would be to take this one away. So why does the ionization energy decrease as you go down a group? Increased shielding with each new energy level. That increased distance causes a decrease in attraction between the electrons and protons. And less attraction means less energy is needed to remove an electron. As you go across a period, the ionization energy increases. The size of our atom is decreasing, so the electrons are being pulled closer to the nucleus, so it's going to be harder to remove those valence electrons. Nuclear charge increases, shielding is constant. As the electrons are pulled closer to the nucleus, there's a stronger attraction, which means more energy is going to be needed to take an electron away. So again, I'm just going to draw myself a little outline of the periodic table. Kind of looks a little bit like a crown. We said that as you go down a group, the ionization energy is decreasing. As we go across a period, ionization energy is increasing. So if we take a look at magnesium and calcium, magnesium is about right here, calcium is about right there. So which has a higher ionization energy? Magnesium is. And then if we look at aluminum and sulfur, the higher ionization energy would be sulfur. And then cesium and barium, barium is going to have a higher ionization energy. Both sulfur and barium are the smaller of those two pairs, so more energy is going to be needed to remove that electron from the atom. And then our last trend is electronegativity. Electronegativity is the ability of an atom to attract electrons to itself when it is bonded to another atom. This is also known as electron affinity. When you have the affinity for something, you love it or you like it a whole lot. So you can also think about this as electron loving. Low electronegativity don't attract electrons. They often lose electrons. So these are going to tend to be our metals. High electronegativity attracts electrons or gains electrons. So these tend to be our nonmetals. electronegativity, as you go down a group, decreases. It's the same as ionization energy. As you go down, it increases or decreases. So why is this? Increased shielding with each new energy level. The larger atom, there's less attraction to the nucleus. As you go across a period, the electronegativity increases. We have a smaller atom because the nuclear charge is increasing, stronger attraction between the electrons and the nucleus. So then let's just draw ourselves a little outline of the periodic table. As we go down a group, the electronegativity decreases. As we go across a period, it increases. So if we look at fluorine and chlorine, fluorine is here, chlorine is here. This time we want to know which has a lower electronegativity. So chlorine would have a lower electronegativity than fluorine. For sodium and potassium, potassium is going to be a larger atom, so it's going to have a lower electronegativity, less attraction to the nucleus. And then our last two are tin and iodine. Well, tin is going to be a little bit larger atom, so there's going to be less attraction for the electrons to the nucleus. So tin will have a lower electronegativity. So I just wanted to point out that electronegativity and ionization energy have the same trend. So if you can remember, electronegativity and ionization energy have the same trend, and just the atomic radius is the opposite of that. That might help you remember which is increasing and decreasing. You have practice on the following two pages. I believe it's pages 19 and 20. So go ahead and take a look at that. You will have a quiz next class over these periodic trends, so make sure you work through that. Come in and ask me any questions before or after school. Thanks for stopping by. Have a great day.